lost my presentation back here. Yeah, okay, I'm here. Okay, thank you very, very much for everybody that stayed until the last slot. So my name is Renato Cavalcanti. If you don't know me, I work at Lightband at the Akka team. And for quite some time, I've been involved with event sourcing and CQRS. And so today I will give a talk that it's a little bit about how I got into event sourcing, the perception that I have about it, why I think I enjoy it, why I think other people don't like it, and how that's a good fit with Akka. And then at the end, I will show a few patterns or anti-patterns, if you prefer, things that I have seen in my life or have in teams that I have worked with or teams that I have given consultancy. People doing event sourcing, but slightly going outside the lines and doing stuff that are not ideal. And then I would like to show some of those patterns so that you get a better understanding why it's a bad thing to take that path and so on, and what are the principles that you have to follow. So as I was saying, I do event sourcing for quite some time now. Since I joined Lightband, I'm not doing event sourcing, I'm building libraries to help other developers to build event source applications. But before that, I was building event source applications. And of course, when I'm in my little bubble, even inside Lightband, well, I deal with people that are also embracing event sourcing, and I deal with clients that are applying event sourcing. So I live in a small bubble where people do event sourcing. But from time to time, I get out of that bubble and I talk with other developers. And from time to time, I find people that say, wow, but event sourcing, I don't get it. Why is that so hard? Or people tell stories about, yeah, we applied that on my company and we will not do that again because it didn't work out for us. And then I start to ask myself why I like it so much, and what kind of person I was when I discovered that, and what helped me to embrace it, and so on. So this talk is a little bit about that as well. So to start with, I want to talk about who I was like 10 years ago. In reality, it's 12 years ago, but I thought 10 years is a better title for a slide. So 10, 12 years ago, who I was. I was a Java developer. I was doing consulting in Java. I named myself object-oriented developer, and I was doing Spring, JPA, Hibernate, the common stuff in the Java world. And you know that when we do object-oriented programming, we tend to create models that try to represent the reality, or to model the reality. And then, just to give an example, we start with a car is a vehicle, and it has tires, and tires of rubber that fit into wheels that are attached to the car, and it moves forward, it eventually backward, and it has an owner, and owner is a human being, and it has a name, an address, a social security number, and it can be an existing customer or a new customer, and so on and so on. And well, being a human being, it can be married, and if it's married, it may have a dispose, may also be the owner of the car, and now I have to model that as well, and then I have to adapt to the insurance contract, and then after I do all those changes and I model all that thing, I put an add transaction on my method, and I persist everything into the database. And for that, I need a library like JPA, or some JPA implementation like Hibernate, that will take that model, deconstruct it, and push it into a relational database. There is nothing wrong with that. I think that for what JPA is built for, they do an incredible job, because it's a hard task to do that, and they do that very well. The problem is not the libraries. The problem, I believe, is the idea that you have to save all that model in one single transaction. And of course, my example here, it's a bit of, it's kind of caricatural example. It's also made for amusement. But I think if you have been around in our industry for quite some time, you have seen applications that are over-designed trying to model too much and especially trying to persist too much data in one transaction, because there is this sense that everything has to be persist altogether, otherwise the system is broken. If you, I taking the same example of a car, if you have ever sold a car, you know, I don't know in your country, but where I live in Belgium, but I think it's similar in other countries as well. What happens is that you find a buyer, and then you have paper, official paper that you have to fill in, and you sign it, and the buyer will sign it as well, and the buyer passes the money, and now for all matters, he's the owner of that car now. She is the owner of the car. Now, this is just a paper. But with that paper, the buyer has the power to transfer the ownership. But for other matters, for you, it's sold. From that point, that's one transaction. From that point, you go, maybe the day later, one day later, one day after, you go to your insurance company and you ask to cancel your contract. And at the same time, the buyer goes to another insurance company, or maybe the same, and will register the car on her name, and will make a new insurance contract. Those are all parts of a bigger transaction, but they are not atomic. You have one special initial transaction, and from that transaction there are other things that happens, and they don't need to all happen at the same time. Another example is if I send money to your account that is probably on another bank in another country, it's not that there is a distributed transaction between my account and your account, that the money is transferring one atomic thing. It's there are many steps. First, a transaction between my account and my bank saying, okay, this money is getting out and it's being sent to another bank in another country, for instance, and it takes a little before the money arrives in your account. So in the world that we live, there are lots of transactions, complex operations, but they don't need to happen on the same atomic transaction. So that was the word that is still the word that's the reality for many applications. No, so and I have been doing that before. No? And I guess that lots of people here have done that as well. And we are talking about an industry that is like 20, 30 years old now. And in 2003, there is a book that shows up from Eric Evans called Domain-Driven Design, with the subtitle Tackling Complexity in the Heart of Software. And I think that the most important part is the subtitle, because it's about tackling complexity. And I think I read this book in 2004, eventually. It was really maybe a year after it got published. And at the time, I found it interesting. There were it's a very dense book. There are lots of concepts inside it. But I didn't see immediately how I could use it. It's okay, nice. There are some things that I can map to my current work, but most of the things I said, okay, maybe I have to read it again later on, and so on. And time passed, and I think in around 2013, 2014, when I was already doing Scala, I discovered event sourcing. And I discovered event sourcing in total unrelated context. It was not because of Scala or because of Akka. And then I said, okay, this has something to do with the book that I read way before. And I went back to reread the book. And there is one concept in the book. That's the concept that's, for me, is the most important. And it's, well, everything start to make sense for me, is the concept of aggregate. And the book defines the concept of aggregate as a transactional boundary. And the transactional boundary, you define a model. So there is the concept of aggregate, and an aggregate is one or many objects that together they need to be persisted in one single atomic transaction, which is similar to what I was talking about the cars and insurance and so on. But there is an emphasis to the fact that this transaction boundary, you should not have two entities, two aggregates that are persist on the same transaction. You have to understand and model your domain and identify what are the boundaries that really need to be consistent. So But that has nothing to do with event sourcing. Event sourcing is another concept that I learned later, and for clarity, the book, Domain-Driven Design book, does not talk about event sourcing. But those two communities later, they converged, and today the DDD community talks all the time about event sourcing and CQRS. There are three different things, domain-driven design, CQRS, and event sourcing, but they all fit quite well into each other, and kind of the communities kind of merged, I would say. So as I was saying, the idea of aggregate is one object, many objects, one or many objects that needs to be persisted together, and because they form a coherent whole, coherent whole. And I would like to use this concept of aggregate to move us into what Akka offers us, and how using event sourcing we can understand that concept. No? So the first, I will start with the first sentence, which is an event sourced. You can build an aggregate, okay? You don't need to use event source for that, but an event sourced aggregate, it's super clean. It rocks. But I go one little further and say that an event source aggregate in Akka, it's even better, because Akka will give you out of the box a few machinery of concepts that will help you build aggregates. So, but before we go into that, I want to give a quick recapitulation of what is event sourcing and what is CQRS. If you're not familiar, you can get a first grab of the concepts here, and then later search a little bit more the details. If you just need a refresh, I think this short introduction will be enough. So the main idea in event sourcing is that you persist events that are considered facts, and they derive all the state in your system. So what you have in your persistent storage are a journal of events. And from there, you derive the states. Then you have, which is another concept, CQRS, which stands for Command Query Responsibility Segregation. And CQRS comes from the observation that the needs to validate and write data are not the same as our needs to read data. And when we try to build an application that writes data, but also prepare the data to be read afterwards, we increase in complexity. There is more work, and that's an important difference. When you separate things, there are more work, in the sense that you have to build something here, and then you have to build something on the other side as well. You have to build something on the write side, and you have to build something for the read side, for the command side, for the query side. So there are more work in that sense, but there is a reduction in complexity. A reduction in complexity because then this model on that side, they are supposed to be very simple and from one single purpose to write data, and the model on the other side, they are expected to be also very simple and optimize it for reads. So you remove complexity by duplicating or separating those two. And the word segregation comes from that. There are two responsibilities, writing data and reading data. They are two different things. And event sourcing and CQRS, they are two different things, but they kind of fit super well together. So I prepared a few slides that are not about Akka. I won't show Akka code, by the way, today. It's not about Akka. It's just like high-level concepts of what are the machinery, okay? So in the right side, the command side, we start with, let's say, a command. I always use this example of the raffle because it's super simple and everybody knows how it works. So the first command is create a raffle, and it has a prize description. I have to send it to somewhere, doesn't matter where for the moment, and I need to validate. Maybe it's ridiculous validation. Okay, create a raffle, I will always accept it, but maybe I have a limit in my system how many raffles I can create a day, and then I can eventually refuse it. Doesn't matter much, but I need to send to some place that will validate if it's a valid command or not. And I'm representing it here with kind of pseudo Scala Java code, like raffle.validate. It looks like a method on a Scala object, like a static thing, just to that people can follow the main idea. So you validate it. And if it's a valid one, it will persist an event. And the event, and note that there is create raffle is imperative tense, and raffle created is a fact. It's in the past tense. Something happened now. It's persisted. Now I have to deal with that. From that point, I can apply that event and generate my raffle. Exactly. So think about this first slide as the constructor that validates the invariants of the input parameters in your constructor. And if you're good, you get a new object created. But here there are one step in between. You represent things, the mutation using events, and they got persistent, and then they got applied. Life goes on. I got a new participant or the first participant for that raffle. And then you have to ask yourself, is this already memory? Yes or not? If not, do I have things in the journal to read? Well, eventually I have to first replay the events. I bring back my raffle into memory and I apply my new command. If it's the first participant, it's okay. I always accept. If it's my second one, I may want to verify if the participant is not double booking, because it will increase its chance to win the raffle. So maybe I have this business rule, and I will create a new event. I persist, and I now apply that participant added to the new raffle. That's the read side. So there is a machinery here that's always the same. Command comes in, needs to be validated either against some static thing that I have to put somewhere, or to some model that I bring into memory that has some data already. I validate against that. I decide if it will persist events, and I apply the event. So there's this machinery is always the same. As simple as that. You just need to encode things and model your domain. Write side, no command side. On the read side, well, what we have there is a list of events. I will have a journal, a store somewhere, and when I read it, I will say, okay, give me all the events. I didn't put the IDs here, but let's say that I can read my storage and say, give me all the events for raffle 1, 2, 3, defined by 1, 2, 3. And I say, okay, I have 3 participants, and I select a winner, and that's it. That raffle 1, 2, 3 is finished. No? And the read side actually is pretty much simple. It's just about reading data and producing new data from that. While the write side, there is this validation part. No? And this machinery, first I have to replay, accept the command or reject it, produce events, apply the events. They're a little bit more complex. But what are the implicit rules that we have here? So I showed us the machinery of the right side, but what are the implicit rules? There are some implicit rules that I will try to make them more explicit. First, you pass one command at a time. So each time, that entity has to serialize the commands that are coming. You cannot handle 2 at the same time because you risk to create inconsistency. So it needs to accept 1 at a time. There is this idea that you have to instantiate or load something into memory. You have to replay some state. Read the journal, replay everything back, reconstruct something, event source, you reconstruct the state from your journal. This needs to happen. Another concept is that the aggregate is the guardian. It's there to make sure that every event that we persist are valid according to some business logic. So if a user tries to subscribe once again on my raffle, I have to reject that command, and I cannot accept that twice the same participants have subscribes to the raffle, because it will increase their chance. No. Just so it must take care that the model is always consistent. there is a place somewhere where the events get to be persisted. And we didn't talk about how to model that. And that's on purpose because the events, they are there to be replayed. So what you persist are actually the blob of your events. You serialize them to some format and you put that on disk. Of course, you need some extra columns to be able to fetch it out. For instance, I need a persistence ID to be able to fetch all the events from one given raffle. But you need to have this kind of infrastructure somewhere. It means that the events needs to be serializable. So these are all implicit in these slides that I'm trying to now to make them more obvious. I talked 3 times about apply. So there is this apply validate. You apply the command, you validate by validating it, decide if you reject or if you accept. Accept can be I accept, but I don't emit events. Accept can also be I accept and I emit one or more events. And by that, it means that there is a method that you have to implement that contains your business logic. Actually, it's the real business logic of your model where you decide what is a valid command and what needs to be emitted as events. But we also use the term apply when I'm applying the events. So the first one is the command handler, where you decide if that command is valid, a given command is valid. And the other side is the event handler. And again, there you take the state and you apply and you create a new state. It's like a fold left. What happens there is that when I reinstantiate my model, I have to replay my events. It means that I will call the event handler once again to replay them back, like in a fold left. And I like to say that, so this is my interpretation of my extra. This concept of aggregate in DDD, I like to say that the aggregate is not only the DDD concept of aggregate, but it's also the aggregation of all the events that you have in the journal. If you think about a fold left, the aggregate is the accumulator that goes over all the events, and you end up with all the events aggregated there. You apply each of them and you end up with one aggregate in your hands. So there is a similarity there, but that's not what the DDD wants to say with aggregate. I just make that parallel with Scala because of fold left, and I usually call it ACK from accumulator, but you can also call it an aggregator inside your fold left. But when you're using Akka, you even don't see that fold left. That's because Akka does that all for you behind the scenes. So as I was saying, so the event handler, they get applied more than once, and that's very important that they need to be pure. Sometimes I see people say, okay, an event happened. So in my event handler, I will send an email. And then tomorrow when they reinstantiate that model, they send an email to their clients. They say, well, but I didn't want to send an email. Yeah, but you put a code in the event handler. That's not a place to create side effects. That's to update your model, and it has to be pure. Preferably, the command handler should also be pure, but there you have, it's less risky. But the event handler, it really needs to be pure. But how Akka help us here? So we talk about the implicit concepts inside the command side of the right side. So how can Akka help us here? The first thing is that Akka works with a mailbox. When you have an actor somewhere, it has a mailbox, and you cannot talk to the actor directly. What you do, you talk to a reference to that actor, and you send a message, and it goes to a mailbox, which is make sure that things get serialized for you. Each command that arrives in the mailbox are delivered to the actor one by one at order of arrival. And that creates this isolation, that idea that it's one command at a time. It's one actor, one mailbox, one thread, one command at a time. And that, by design, makes that if you model an aggregate using Akka, your aggregate is by itself isolated. It's one thing. And you can only talk to that one by one. And And that's even not only about persistent actors. Any actor is like that. This is just like a built-in feature of an actor model. So it gives you aggregate isolation by design. The other thing is all the machinery to persist things. So you have Akka serialization, which is a library, tooling or a part of Akka where you can specify how you want to serialize objects. You need to serialize to some form, preferably not using Java serialization because there are lots of issues, security, performance, but we recommend protobuf, Seaborn serialization, or even JSON. So you need to serialize, and Akka has that already for you. And you need the machinery to do the plugin, to replay things, and so on. And that's what Akka Persist gives you, and we have lots of event plugins for that. And that's the write side. And on the read side, you need to be able to read the event to produce new data, to produce views, reports, to send to other systems, and so on. And for long, we had Akka Persistence Query to allow you to query the event journal. But since 1.5 years now, we have Akka Projections, which is a new project in the Akka family, and it helps you to read your journal, but track where you stopped. It helps you to consume a journal and track the offset. So every event in a journal, you can track by ordering number, and Akka Projections will help you track it out. And of course, if your system stops, it will, when you recover, it will start over from the last offset it consumed. And as such, you can use Akka first to produce data on your write side, and then to consume data on your read side. You're going to use Akka Projects to generate all kind of view concerns, like views, really things that you put on the screen on your web browser. Statistics reports, you can use Akka Projections to consume events and put on a broker, and Akka Projects helps you maintaining and keep track where you are. So this is a Twitter from Vaughan Vernon. It's a guy that's very active in the DDD and event source community. Some time ago, he was also involved with Akka. He wrote a book about it as well. And once he quoted a team member of him saying, using actor model with event source and secure as make it feel like we are cheating. And that's pretty much true, because if you see the other options we have out there, you have to build all the machinery. And with Akka, all the machine is there for you, plus clustering, which I'm not covering today, but it's a super powerful abstraction for building event sourcing as well, to be able to scale horizontally your application. But now the question, why would you do event sourcing? No, so I have a few slides here, and as everybody knows, rectangle with shapes inside represents a monolith. So what I am trying to represent here is one application with a few components inside. 4 shapes representing different parts of that application, and they call each other by calling methods on it, just API calls. They are all on the same process. That's all fine. I'm not against building monolith, but when you need to break it down because you need to scale and refactor parts of it, and you know, the first thing that people do, which is a mistake to my opinion, is to refactor that in 4 different applications. So removing the idea that they are one single application, but then you're not yet building a microservice, you're building a microlith. And that's how we call it at Lightband. And at the end here, you're paying the cost of maintaining 4 applications, and you're increasing the latency between them. Now, those 4 different applications, they call each other by just doing REST calls or gRPC or any other protocol you want, but they are blocking calls. And that's not efficient. So now you pay the price of building 4 applications, and you pay the price of latency. So the goal here, and that's why event source is important, is that if I can represent my mutations in terms of events, I can now propagate my events into some publish my events into some broker that the dependent applications can consume from there. And now I can scale my applications, deploy many nodes of them, and they are kind of independent of each other because they depend on broker. And broker is very often is Kafka, and it's built for this kind of systems, and it's a way to decouple those applications. And eventually the Pentagon application goes down because it's in maintenance. The triangle keeps going because there's still data in the broker to be consumed, data that comes from the Pentagon. But now the triangle doesn't matter. It doesn't need to know if Pentagon is there or not, producing that or not. The only thing that the triangle application can see is, okay, I have data to consume, so I keep consuming. And when there is no data, so there is nothing for me to do. The Pentagon application comes back, and continue producing data in the pushing data into the broker, and then the triangles start to consume that data, and that's all fine. So now we have a topology that allows us to replace one part of my application and have you do have event of consistency because data needs to flow around, but each of those applications, they have their own isolated words. They should encode their own aggregates with their own business rules, being persisted with events being persistent in their own transactions, and the other, they are dependent on that, but indirectly. So that's the whole topology that we want to have. Of course, it's on you to decide if a microleaf, not a microleaf, a monolith is good for you, fine. If you need to move to a more modern deployment, a different topology because of your needs, then you go for microservices. But going between, that's the worst you can do. Either you do a monolith or you go full event source in microservice. Or, okay, you can have situations where this kind of latency is acceptable, but you need to analyze what you really need for your application. Ultimately, microservices, the most performant one is one that is based on event sourcing, because then you have this full decoupling. Now, we still have a few minutes, so let's go to the part where I will tell some horror stories or tips, things that you should avoid or watch out. So the first, I select, I think, 4 or 5 patterns or patterns, and the first one is the golden hammer. I want to start with this one because is the thing that I think that many developers do is like, I find it cool, I want to use it, and let's do it tomorrow. But yeah, sometimes just old code is all you need, and you have to use good judgments to, okay, do I need to use event source? Yeah, it's super cool. I personally find it's a very clean way to model your business domain. When you start to think about the commands and the events that it has to produce, the business rules inside the command handlers and the event handlers, it's very clean, but it's a different approach. And do you need to apply this technique everywhere? So use good judgment. Maybe sometimes you just need CRUD. So don't use it as a golden hammer. The other one, and I have seen that a few times, is the fake aggregate. So the idea of event sourcing, building aggregates, is to model a business domain that has some business invariants that they have to protect. You have to protect the data. You have to make sure that the data that you produce are consistent with the business rules. But sometimes people build aggregates that has no validation, and the commands comes in and they get persisted. Sometimes they get a command in and they transform to an event and they persist the event. Sometimes they even don't take the how to say that, the work. They don't take their time to, they don't care, and they just persist the commands as is. But when you're doing that, you're not doing DDD, you're not doing validation, you're not building an aggregate, you're not creating a transactional boundary, you're just transferring data from some endpoint to some journal or broker. So if you have an aggregate with zero business logic that accepts everything, actually you are creating a buffer. You're probably consuming data from one side, putting data in the journal that you can later consume. It's like a poor man back pressure. You cannot consume that now, so you persist it and later you consume. This is not aggregate. You should not build, you should not use Akka for that. You can just pretty much have an endpoint that takes that and puts in Kafka or in some database. So you don't need to go through the whole concept of aggregate modeling if there is no validation. So that's the fake aggregate. So avoid it. Another one, which is the most funny, I think, it's, I don't know, I think in every country, some time ago, there was this TV show that was popular a little bit everywhere, which is Who Wants to Be a Millionaire? And it was a kind of quiz. And then in the program, you could, at some point when you don't know how to answer a question, you could call a friend. I have a friend, it's worked with astronomy. I could call him if there was like an astronomy question. I said, okay, I will call Hans now. And I call him to answer that question because I cannot answer that. So there is no phone of friends in aggregate modeling. An aggregate has no friends. It's self-confident. It answers all the questions. And what I want to say about that is that, someone calling here. What I want to say about that is that the aggregate should be able to validate anything based on the data it has or on the data that is coming in the comments. If you find yourself modeling an aggregate that once a comment comes in, it has to call another aggregate to make the decision if it's allowed to persist events or not, then you are breaking that consistency boundary. How is that possible that another system will tell me if I can persist events? I am the owner of my events. I am the owner of the data. I am the one in the aggregate. I am the one that can tell if those events can be persisted or not. So an aggregate is self-confident. It always answers yes or no, but it never calls a friend. If it happens that you need some extra data, that's not the goal, the responsibility of the aggregates to do it. It's the outside the aggregate, when you get the incoming request, okay, I need some extra data. You go fetch data wherever you need to go fetch data, and you create a command with the data that you got from outside, from the user, for instance, and get data that you fetch from some other place, and you build a command for that. We call it a command enrichment. You don't go from request command aggregate, go request, and then you create a command that is enriched with data from the request and some other data that you collected some other place, and you send to the aggregate. Now the aggregate has everything. It has its own data, and it has data from the command, and now it can decide if it's a valid command or not. So never call a friend. The next one is all you can eat. If you have ever been in a Brazilian rodizio restaurant, a few guys here know what I mean. It's not all you can eat. It's not because you have data that have to keep it around and take all the data that comes in the commands and keep it in the aggregate. I pick here some modeling, very simplified. So you have a trade, a raffle, and it goes from empty raffle to open raffle that has participants and then finished. And as you can see, the commands and the events, they have more data. They have a prize, they have the participant ID, the winner selected has also the winner, but the raffle itself doesn't. And what I want to show here is that the aggregate only keeps data that it needs to validate the next command. I don't need the prize to validate if someone can be added as a participant. That's not information that I need in the aggregate. I do need in my events, because my events, they are there to be replayed and construct my aggregate, but I also want those events to generate views and other things, or to propagate to Kafka so it can be consumed by other systems. So whenever you see yourself adding data in your aggregates that are not, strictly speaking, used to validate commands, then you're creating a fat aggregate, one that it's eating everything that it can and keeping data around. And that's not the ideal situation. In some situations, you can say, okay, I want to do that. It will be convenient for me. But in general, the aggregate only keeps data, the data needed to validate events and to keep the model consistent, not data that is not necessary, should not be kept around. Then the good, the bad, and the ugly. I think if you make a talk about design and design principles, you always need to have such a slide, the good, the bad, and the ugly. So how you should model events. So the first one, the good, are events that are minimum for the business. That if you talk about the business, you can verbalize then things that happens in your business, like raffle created, participant added, participant removed, and so on. Those are meaningful. How granular you need to go, it depends on your needs. But they usually are the verbs in past tense of things that can happen in your system. The bad are things that are not events. It's terrible to see something like participant rejected, unless you have the business rules that say, if I rejected someone for 3 times, that person gets suspended for a while, and then you have a business rules for that. Otherwise, participant reject is an event in the sense that something happened, it got rejected, but it's more ephemeral event, something that you use to send back to the user, say, oh, this thing was rejected, this subscription was rejected, but it's not a real domain event. It's an event. Yeah, it's an event because something happened, but it's not something that you need to persist. I have seen a system that was amazing, how creative it was, because there is in Akka this thing that you should not do ask in Akka, only fire and forget. And people were sending commands, and when they reject the command, they were persistent that the command was rejected. And then that was going to the event store, and then from the event store to Kafka, and then they were subscribing to Kafka to tell the user that, yeah, indeed, that thing was rejected. But there was no business rule requiring that to be there, only the belief that you cannot, if you're using Akka, you should always do fire and forget. And that was a bad design. And they got in lots of trouble because of that. Hopefully we were able to fix it. The ugly is when you're completely missing the point and you create an event that is raffle updated and everything is inside. And here you have all the participants, all the winner, yes or no, it's an option. And actually you're not representing anything as events, you're just transferring all the data all over all the time. Of course, here's a very simplified example. It's not much that, but you can imagine that a more complex domain that becomes like a huge thing that you are just emitting all over the time. You're doing like state sourcing instead of event sourcing. So that's the ugly one. So going towards the end, takeaways for that is, if you want to build event sourced applications, event sourced microservices in Akka or without Akka, doesn't matter. Embrace the part, learn about it, know it, read, practice, follow the principles, and apply discipline. Don't forget the aggregate, that model that you create, is there as a transaction boundary, as a guardian for your journal, to make sure that everything that goes to the journal makes sense for your business, for your application. The event handlers are pure functions, and command handlers preferably. You can diverge a little bit there, but event handlers needs to be pure. Linear. What I mean by linear is that it's the fun of friend. Commands comes in. It's like the aggregates. They are the leaves of your system. you don't go from an aggregate, you don't start a branch of processing, going to some other place and then back and then another one. Things ends there. You got the command journal and back. So it's at the end of your system, of your mode, of your application. Usually, event source applications, they are quite simple in the sense that you have endpoint, request comes in, they become command, they go to the event, to the aggregate, things get persisted and back. That's it. Very linear. Don't try to branch things and go. Make sure that one command, one aggregate, one journal, and back. You don't. It's one transaction. No. So this linearity is important. Now, those are principles, and as Groucho Marx used to say, those are my principles. If you don't like, I have others. It's good to follow principles, but yeah, sometimes you may need to diverge. But the worst is when you diverge because of ignorance. Diverge because you know that now it's time to do it, and because you come in a situation and say, okay, now I won't apply the principles, and I will allow myself to do something a little bit different because you are in control and you know what you're doing. So that's why the first one starts at learn it, read about it, embrace the pattern, and then you're allowed to diverge. The worst thing is when you diverge when you don't even know you are diverging, because you're trying to build applications that, with another mindset, and you start to diverge because you are not embracing the pattern. To finalize, I want to leave you with a few links. So we have two things here. First is the Akka Platform. Is a guide, like a huge tutorial that we wrote, how to build microservice applications, event sourced applications using the Akka Platform. It explains all the concepts, not only write side, read side, Akka persistence, one side, Akka projections, the other side, but also clustering, how to deploy, how to connect to Kafka, and so on and so on. So it's the intention of the guide is really to guide you through the whole process. And Akka Serverless, we have, if you have been following what Lightband is doing, we are building Akka Serverless, the Akka team and other teams inside Lightband. We are everybody work on that project now, and it's about doing that, but then in a serverless setup. And we take care of the persistence. You just come in and you write your code. And the good news is that we recently released the Scala API for Akka Serverless. That's it. I hope we still have time for questions. And yeah, here my Twitter handle and email address if you want to reach out later on. Thank you very much.
Thank you so much for that wonderful presentation, Renato. And we do have a few questions for you. And I've got to say, also, there is no such thing as phone a friend at ScalaCon. So I hope you're ready. All right, our first question. Seems like CQRS and event sourcing will be tightly coupled to eventual consistency for data. Is there a way around it if we really need stronger, faster consistency, or just use diff patterns altogether?
Yeah, that's a very good question. It's so when talking about Akka, then you get into event consistency, because the Akka persistence APIs, they are built to be append only, because when you do append only, you increase your throughput. If you want to, there are other CQRS frameworks out there in the Java world, for instance, Axon.io. What they do is you can choose. You can choose if you want event consistency or if you want to generate your view together. But when you do that, then you have to do like optimistic locking. For every event that comes in, when you persist, it has to go to the view, update the view. Eventually, it will fail because the view cannot be updated. So you increase you increase the latency because you need to do updates, fetch and replace in the database. So Akka persistence is built to do append only, so it forces you into event consistency. If you cannot accept that, if it's too much for you, then the diff pattern, it's an option, which is you have one model, you are not doing CQRS, you have one model, and you once you persist, you derive something that is not really an event, but you emit events that are never applied to your model, but it's things that you generate to put in some broker, and it's like the diff pattern. And then you have to take that path. Yes, indeed.
All right, wonderful. Our next question is, I'm a bit confused when we talk about validation in the context of CQRS. Validating an HTTP request is easy. We can just return 400 and reject it. But what does it mean to reject an event?
Yeah. So we don't reject events. So there's also sometimes it's also a confusion. We reject a command. So and indeed, let's take that scenario. You have a valid an HTTP endpoint. There is a request coming. So you get that request in kind of controller, and in your web controller, you take the data coming from outside, and you're going to build a command from that. And that command, let's say I say add participant, I will now have a command that I derived from that request, and I will talk to my aggregate and send that command. The aggregate can say, no, reject it. This guy already subscribed here. So you take that response from the aggregate, that rejection, and you transform to a 400 of some sort to the REST API. So you do that bridge between the REST and your aggregates. And at the end, what can be rejected is a command. Events, they are facts, things that happen, they are persist to your journal, and they will be applied to your domain. And that's why the event handler needs to be pure, because they are replayed each time you need your domain. It's brought back into memory, replay it, and needs to be pure. So events are never rejected. You should always be able to read them back and replay. Commands can be rejected.
Okay, thank you for clarifying that. Our next question, what are the benefits of using Akka for event sourcing over Kafka RPC systems?
Yeah, that's a good question. The thing about Kafka is that it can work, but when I have a model and I want, imagine the following situation. I have a model and I want to replay it back into memory. If I'm using Kafka, I cannot in Kafka say, give me all the events for the model identified by ABC. You have to subscribe to a topic and filter out everything that you don't want and only pick the events from that aggregate. So it's more on the replay side that Kafka is not a better, it's not the best match you can have. You want a journal that you can cherry pick only the events for that model, so you can replay. The RPC question, I don't know if I understood. I guess it's connecting to some streaming RPC of some sort, so maybe the person can clarify. But I think it's the same kind of, if you can have a journal, event store that you can cherry pick only the events that you need, then you have everything to build an event source system. And Akka gives that. Others also, you can build your own as well, of course. It's not rocket science.
All right. And moving into our final question, should the persisting of an event be allowed to create a command? Yeah,
I guess that's the point of the question is, I have a command comes in, I persist an event, and that event now will trigger another command. And then there are two things you can do that. If you trigger another event, another command, it's the situation like calling a friend, no? But it's a little bit different because you're doing that after. So you persist the event, and now I need to trigger something. It's a side effect. You can do that, but you cannot do that inside the event handler, because as I was saying, the event handler is used to replay your state as well, and you're gonna send again that command. You need to do that in another way. Akka offers that. When you have a command handler, you can say, okay, I will persist events, and when I'm finished, do that. It's a side effect. But the side effect is at least once. If your system breaks at that point, and then do that may not happen if your system crashed. So that command may never be sent. It's at most once. The alternative to that is to subscribe to the journal using Akka projections and say, okay, this aggregate emitted those events. I'm now subscribed to that journal. And when I see that event coming in, I will send a command to that other aggregate. And Akka projection has this functionality. You can, when you build an Akka projection, you can read from different kind of source, not only the journal. Doesn't matter much for that example. Let's say that you will read from the journal, and you can say send commands to a database to create views, but you can also send to an actor. You can also send to another aggregate. So this pattern is there. It's just, but the best is you subscribe later. If you do as side effect, is at most once. If you do with Akka projections, is at least once.
Wonderful.
I hope this answered the question.
Absolutely. Well, thank you so much again for taking the time to answer those questions. Thank you for your talk. And of course, thank you for joining us at ScalaCon.
Thank you.